because this idea is very important. Yeah. The details, yeah, because we will use existing tools. We will not write our own hashing code. Okay, so in Java, we use the hash table, hash map, so the algorithms is already built in the class. So we do not need to write our own code. We just use it. So here, I just give you the background information. So when you use, you understand, what's the basic design idea behind this technique. Yeah. So that's what I want to do here. All right. The first part. Why using hashing? Okay. All right. The reason. Yeah. Oh yeah. Sorry. All right. Yeah. So let me explain a little bit. This our current situation. So, under what situation, then we need to use this technique. Yeah. All right. So the topic here is the search. Now we need to. This is a search problem. Okay. Search, sort, selection. So this is the search problem. The search problem, we learned the first one, linear search, right? Linear search. Yeah. Linear search, the efficiency we know is big O of n. Linear search, okay? All right. But linear search for unordered array. Unordered data, okay, all right. Then binary search. Second type. Big O of log n. Okay, but must be unordered data. Ordered data, okay, yeah. Otherwise, you cannot apply the binary search. All right. Then the third one. So that's hashing. Yeah. Also the search type algorithm. Okay. Yeah. Then you will see the average. So here we're talking about the average. Yeah. Not the worst case. Okay. Not the worst case. So here, the average case. Average case is big O of 1. How good it is. How good it is. And the data unordered. Yeah, so why it is so fast, right? Even faster, here you can see, even faster than the binary search. How can that happen for unordered data, right? How can that happen? So, yeah. So that's why, so this technique, okay, I really want to give you the idea. Yeah. Yeah. The detail, because, we have existing tools we can use. Yeah. So we don't need to write our own code. Yeah. All right. Yeah. So let's look at that. Now, how to find a data item with a given key? Yeah, that's the search problem. Now, given key, we need to find, in our data, collection of data, array, in our array. So, how to find it in a very fast way? Yeah, all right. Give a collection of data dynamically. Yeah, all right. Each data item is identified with a unique key. Yeah. All right, so the search key. Then we use that search key. We try to find the data item in a very fast way. Yeah. Question, how to make your data search efficiently? Okay, the goal. Yeah. All right. Yeah. So here, we need to consider the data structure. Yeah. Yeah. The Module 5, advanced data structure. So here, we need to do some work in our data structure. Yeah. Yeah. Current array, yeah, you know, yeah. Not good enough. We need to add more structure in the array. Yeah. All right. Yeah. So here we have freedom to choose. Yeah, because nobody tells you you have to use this way, that way, right? You have freedom to choose your data structure. Yeah. All right. So, and we want to handle dynamic data efficiently. So what do you mean dynamic? Yeah, because after you store the data, then a new data comes in. You need to quickly insert the new data item in your data structure. Yeah. Yeah. If you need to do a lot of work, then it's not good. Okay? Yeah. So this dynamic data support is important. Yeah. All right. Then examine our non-search algorithms. Yeah. All right. Linear search, binary search. Then there is one special search people call. Yeah. But it is not popular. Yeah. It is rarely used. It is rarely used. Okay? But this one is very special. It has some very special property. Yeah. And we want to use this special search type to get inspiration for this hashing technology. Yeah. Yeah. So what's that? Yeah. Next slide, we will see it. Yeah. Index search. From the name, you know, yeah, using its index, so you're fine. Yeah. Index search. Yeah. Data structure, array. Yeah. Performance. Yeah. All right. The index search is given array. There, if you use index as the search key, can you find your element in bigger of 1? Because you have the index, right? You can get to that location immediately. Yeah. That's why bigger of 1. Very fast. Yeah. But it is a big drawback. So it cannot be used in the real world applications. Big problem. Yeah. It cannot be used. Yeah. So I will explain that. All right. Ordering unsorted, sorted, unsorted. Yeah. Yeah. Dynamic, yes. Yeah. Costly, yeah, because the binary search, your data is ordered. When you add a new data item, in order to make the whole array ordered, you need to do a lot of work. Yeah. Yeah. So that's costly. Yeah. Yeah. All right. Yeah. Efficient sorting. Yeah. Yeah, because random array, you need to apply the sorting algorithm, so not efficient. Binary search, already ordered, then if you want to return ordered information, then very, very fast. Yeah. No. Okay, all right. Yeah. Then our new search algorithm. Yeah. We need a new data structure. Yeah. And we want to have the similar performance, big of 1. Yeah. But for the average, not worst case. Worst case, it cannot be bigger of 1. Yeah. And unsorted. Dynamic data, yes. Yeah. All right. Efficient sorting, no. You cannot have everything. Yeah. If you want to get your data sorted, you need to do a lot of work. Yeah. So that's our design goal. Okay. All right. So the properties we want to have. Yeah. All right. Yeah. Then next, I want to describe the idea of index search. Yeah. To get inspiration on this new technique. Yeah. Hashing. Yeah. All right. So, generalized idea of index search. Yeah. I already give you the main properties. So you have an array, store your data. Then, how do we store the data? The question, how do we store the data? Okay? Yeah. We use search key as the index. We use search key as an array index. Okay? Yeah. But this property may cause a lot of problems. Search key. Yeah. All right. In our textbook, it is called a direct addressing. Direct address. You use search key as the address. That's the direct address. It's not an indirect address. It's not, when you use a search key, you do some operation on the key, then you get an address. It's not that. Direct address, you take the search key, that's the same as your address. So that it is also called direct addressing method. Yeah. All right. So, yeah. The key property, yeah. Yeah. One-to-one correspondence. Search key and index of array. Yeah. The same thing. Yeah. One-to-one correspondence. Yeah. All right. Then the main problem, why nobody uses it in the real world situation. The reason is very simple. Because the search key could be very large, right? Yeah? Yeah. The search key, yeah, arbitrary search key in the real world. That means if you use the search key directly as index, your index number could be very large. Yeah. So look at, when the keys are long key. Yeah. For example, your student number, how many digits you have, right? Social security number, how many digits you have. Then, this direct addressing method, you use the same number as the index of array. Then your array is huge, right? Huge array, yeah, all right, yeah. But you only have a small number of elements, yeah? You do not need to use that large array, yeah. Yeah. So you have dozens of elements or hundreds of elements. Why you need to use that huge array? Yeah. That's the main problem. Yeah. Okay? Too much space. Yeah. All right. Waste a lot of space. Yeah. So that's why nobody uses this method in the real world application. Yeah. But why we talk about this bad algorithm here? Because we can get very important inspiration for our hashing method. Yeah. All right, the problem here, right? Yeah, key, long. Can we do something special to make it key shorter and do not waste that much space? Yeah. Yeah. Reduce the wasted part of the space. Yeah. 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 We may waste some space, but much smaller. Yeah. Yeah. Because we need some room, okay? So we may waste some space. Yeah. But, not too much. Yeah. Yeah. All right. How to use space efficiently? This question. Yeah. Long key, yeah, yeah. For the long key case, yeah. Think about it. 40 students, if we use the student number or student number, let's say. Yeah. Yeah. Student number, then only 40 students. That student number, why you need that big array? Yeah. So, yeah. All right. Yeah. So that means the direct way is not good. Yeah, we should use indirect way. Yeah. We need to do conversion. Yeah. All right. So how to make keys shorter? Yeah. The next question, we need to do some special operation to make the, key still original key, but we know when we go from key to addresses, we need to do some operations. We cannot use keys directly. We need to do some special operations on the keys to get addresses. That's the idea. Yeah. The question, how to do it? Okay, all right. Yeah. How to map keys to the slots. Yeah, here we have, relatively small number of slots. Yeah, yeah. The keys usually quite long. Okay, so how to do that mapping? Yeah, mapping keys to the locations of the slots. Yeah, all right. Mapping strategy. All right. What is a good mapping here? Yeah, fast calculation. Yeah. When we do mapping, that means you need to use some math functions. Math functions. Yeah. Yeah. How to map keys to address numbers. Yeah. Plugging in some math key functions. Yeah. But your math key function should be, when you do calculation, it should be very fast. Otherwise, too slow, then your algorithm will be slow. Yeah. So fast calculation, evenly distributed among all slots. Yeah. This is another important consideration. Evenly distributed. Yeah, you have certain number of slots. Yeah. When you map your keys to the slot numbers, if your mapping function, if your function, hash function, later we will call hash function, yeah, map most of the keys to some relatively small regions in the slots, then it's not good. Then you waste a lot of unused slots, right? You waste. Yeah. Yeah. So then your algorithm won't be fast. Yeah. So a good mapping function should have this property, evenly distributed among all the slots. Yeah. Spread out. Yeah. Spread. Covering all the slot numbers. Yeah. Yeah. It's hard. It's not easy to get this property. Yeah. Not sensitive to any pattern. That's another important consideration. Not sensitive to any pattern, because your key, the keys you have sometimes may follow some special pattern. Yeah. So if your mapping function is not very robust, then under some special patterns, then you map most of the keys in a relatively small region. Then it will be very slow. Yeah. So when you design a good hash function, you need to consider these three properties. Yeah. All right. Implementation. Yeah. Yeah. So then the main step, design some good math functions. Yeah. All right. Yeah. Yeah. Hash functions. Yeah. All right. So here, I just want to give you the main ideas of two types of hash functions. Yeah. Simple type. Yeah. Yeah. All right. The first one, division method. Yeah. So let me look at the time. I need to control a little bit, because I need to leave at least about 15 minutes. I just talk about, the final question types. Yeah. Yeah. All right. So, yeah. 15 to 20 minutes. I talk about the final question types. Yeah. Yeah. All right. Yeah. All right. Division method, very simple. Okay. Yeah. Division method. Assume all keys are natural numbers. Yeah. So here, for simplicity, we assume that. Yeah. Because later, this hashing way, we can apply on string values. Yeah. But string values to natural numbers, we can do conversion, right? Yeah. We can do some simple conversion. Yeah. 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 So here, if we use the natural numbers, then we can do math operations, right? If you string, you cannot do math operation directly. Yeah. All right. So non-natural number keys can be converted to natural numbers. Yeah. All right. And we assume there are m slots. Yeah. All right. How to map a relatively large key k to one of the slots? Many different ways. Yeah. The first simple method, division method. Yeah. Just this hash function, hash of h of k, you mod slot number n. Straightforward. Modular operation, take a remainder, well, you take the remainder, yeah. Then you get a slot number. Simple. Yeah. But this function is not very good. You can see, although very simple, yeah, not robust. Okay? Yeah. Yeah. All right. So easy to calculate. Yeah. Yeah. Evenly distributed, usually not. Yeah. Especially when you have some special pattern. Then this method can, performs very poor. Yeah. All right. Depends on the keys. Yeah. Yeah. So here we can see some simple example. So what kind of special pattern? So we can, get some big problem. Yeah. All right. So here in this example, let's consider m, simple case, 15. 15. The simple case. Yeah. And our hash function k mod 15. Yeah. All right. When we use this simple hash function, now let's consider our keys have some special pattern, multiple of 3. That's the pattern of our keys. Okay, multiple of 3. All right. Yeah. But when you apply your hash function key, h on this k, you also get a multiple of 3, right? Yeah, because this 15 is a multiple of 3. You do the modular operation, remainder also multiple of 3, right? Yeah, yeah, yeah. So then, yeah, because this is the remainder, okay? Original number, the difference between the remainder, original number, it should be multiple of 15. That's the definition of modular operation, right? Yeah. Then you can see this h function, yeah, equals this value, but the k is multiple of 3. 15 multiple of 3. Yeah. Yeah. That means if the hash value is the location, slot number, then the slot number, all your slot numbers multiple of 3, right? Then you only use 1/3 of the slots, okay? If it's not multiple of 3, then you cannot map it to those locations. Yeah. So 2/3 of the slots are wasted if you use this bad hash function, okay? Yeah. So this pattern can easily break this hash function. Okay? Yeah. Yeah. So this simple example tells us, in order to make our hash functions more robust. Yeah. So when we use division method, we should choose the, some special number. Yeah. 15 because 3 times 5 is 15. Yeah. So that number is not good. 3 times 5. Yeah. So here the first improvement, use the prime number. Prime number you cannot split as, only one at that number. There is no smaller factors, right? You can split. Yeah. So prime numbers is better than composite numbers, right? 15 is a composite number. Yeah. It's not good. Yeah. So you should use the prime number. But another example, m is power of 2. Yeah. Power of 2, when you use the modular operation, the pattern, because when 2 keys have the same last R bits, then you map them to the same slot. Because modular operation, you truncate the bits, right? Last R bits. You only take the last, before that last R bits, you truncate it. You throw away. Then, if you have the same last R bits, then all those keys are mapped to the same slot. So that's not good. Another case, sometimes some pattern may cause the problem. Yeah. All right. So, then a good choice for division method. A prime number that is not too close to any power of 2. You try to avoid, those 2 patterns. First, prime number. But prime number, if it's very close to power of 2, that's still not good. Okay? Yeah. So not very close to power of 2. Then it's better. Okay? Yeah. All right. Yeah, but overall, this division method is not very good. So even you try very hard. So the overall division method, when we want to, break all the patterns. So we don't want our hash function perform poorly for some of the patterns. So it's not easy for that. All right. So here, so we want to do better. So we want to find a more robust method than this division method. It's simple, but not very robust. Okay, too limited. So when you choose the numbers, too limited. All right. Then next, improved, better one, multiplication method. Multiplication, then you can see, it's much easier to avoid those patterns. So we have a lot of relatively simple ways we can break those patterns. All right, idea, pretty simple. Hash function design. This time we use multiplication operation as our main operation. Okay, all right. Choose a constant A this time. When you do multiplication, you need to choose a special constant A in the range between 0 and 1. Not integer, okay? Not integer, between 0 and 1. Then your hash function you design this way. Okay. K times A. Then it becomes larger, right? Larger. But you mod 1, you remove the integer part. Mod 1, you only keep the fractional part. You throw away the integer part. Okay? Only keep the fractional part. Then you multiply m, your slot number m. Slot number m, multiply that fractional part. Okay? Fractional number. Okay. Because it's not an integer number, so you take floor function. So this special method, it's the multiplication method. Yeah. First, this number, from the values you can see correspond to the slot numbers, right? Yeah, less than m. Yeah. Okay. Yeah. Greater or equal to 0, but less than m. Yeah, because less than 1 multiply with k, larger, but you throw away the integer part, you get a fraction, right? M times a less than 1, fraction is less than 1. So this number less than m. You take floor function strictly less than m, right? Yeah. So at the most n minus 1. The largest number of this floor function, m minus 1. Yeah. So you get a value from 0 through n minus 1. That's the slot, all the slot numbers. Yeah. But you can choose good A constant. So then you can, easily beat a lot of patterns. Yeah. All right. Yeah. All right. Yeah. So a good selection of A can break most of the patterns. So what's a good selection of A? Yeah. A should be an irrational number. Yeah. Yeah. So if A is a very bad number, ugly, bad number, then the performance is better. Okay? Yeah. The hash function will be better. So it should be irrational number. I think irrational number, right? Yeah. If we look at the fractional part, irrational number, after the decimal point, there is no cycle. Okay? Yeah. Irrational, no cycle. Yeah. Rational, you may find a cycle, right? Yeah. You may find a cycle. Repeated cycle. Okay? Yeah. Irrational number, no cycle. Okay? Pretty much like a random numbers. Pi, think about the digits. Pi. Okay? Yeah. Square root of 2. Yeah, no cycle. Yeah, if you write, infinite many digits, you can never find any cycle in those digits. So that's the rational number. Okay. Irrational number, yeah. Why the irrational is better? Because your goal is to break the pattern, right? Yeah. If you use rational number, then you can find some pattern to make it perform very bad. Yeah. So here, irrational number is better. Okay, all right. Golden ratio is a good one. It's an irrational number, right? Golden ratio. Okay, yeah. All right. Yeah, yeah. Because you remove that one, so you only take this, as the A. Yeah. Yeah. All right. Yeah. A perfect hash function. So then, people may talk about perfect hash function. Okay, yeah. Actually, it does not exist. There is no perfect hash function. Yeah, yeah. But here, what do we mean a perfect hash function? Yeah. What is a perfect hash function? Yeah. Always map two keys to two different slots. That's perfect. Okay. Yeah. Yeah? Yeah. 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 But it's very hard. Yeah. It's impossible. No hash function. We can say this way. Yeah. No hash function can do this. Yeah. Mapping two different keys to two different slots. Always, all the time. Yeah. Yeah. Sometimes your hash function may map two different keys to the same slot number. Same slot number. Okay. In that situation, we call it's a collision. You get a collision. Okay. Yeah. So two different keys. Yeah. You know, you need to go to the same location that get a collision. Yeah. But when a collision occurs, then you need to resolve that collision. Okay, so you need to, you know, design your hashing algorithm to resolve that collision. Yeah. 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 There are many methods to do it. Yeah. But the problem is, although you have various algorithms to help you resolve the collisions, but the problem is, when a collision occurs, you need to do more work, right? If no collision, then you're done. Okay, you'll find a, you know, vacant location for your data. But if you have a collision, you need to, you know, go to the next slot number. Then you may have another collision, right? Then you need to find another different location, another collision, right? So you may hit multiple collisions. Then your algorithm will be very slow. Yeah. So the collision rates, high or low, may impact your overall performance. If your collision rate is very high, then your algorithm will be very slow. Yeah. Yeah. All right, so that's an important factor. It's a collision problem. Two keys are hashed to the same slot. Yeah. Although we cannot avoid it, yeah, nobody can avoid that collision problem, but people want to control to make that collision rate as small as possible. Yeah, not too high. Okay. Yeah. Then when we consider the average case, then the average case efficiency is still very good. Yeah. 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 All right. Yeah. Conclusion. Yeah. No hash function can avoid the collision problem. Okay. Yeah. All right. All right. Yeah. All right. All right. So that's the short introduction. Yeah. So I give you. Yeah. Yeah. Next, let me talk about question types of final exam. Yeah. Yeah. Basically, we follow the you know, our homework assignment. Yeah. Yeah. Similar to midterm. Yeah. So how do we do the midterm? Yeah. So we will use the same way to do the final. Yeah. Right? Midterm. Yeah. Midterm, part A, right? Yeah. And part B. Yeah. Yeah. Actually, we have part C, right? Yeah. 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 All right. So our final, similar. Okay. Yeah. But our final, we won't split part B and part C. Yeah. Yeah, because I want to complete the final, you know, that computation part. Yeah, part A is still online, yeah, as a quiz number 5. Yeah, but the part B and C together, yeah, from the content we split part B and part C. But as a test question, you need to complete in that 2 hours. Okay, 15 questions, part B, part C. Yeah. Yeah. All right. Yeah, let me write a little bit. Okay. Final exam. Let me use this next slide because I have a lot of space. Next slide. Okay. All right. So final exam. Yeah. All right. Monday, May 12th, 5:30 to 7:30, right? Yeah. Yeah. Monday. Yeah. Our usual class time, right? We just extend a little bit. Okay, 5:30, 7:30 p.m. Okay, all right. Yeah, this room. Yeah. All right. Yeah. Then you can use your laptop. Okay. Yeah. Same as midterm. Yeah. The rules, all the rules, the same as midterm. Yeah. So I do not need to repeat. Yeah. You just recall your midterm way. Okay. Yeah. How to do it. Yeah. Then part A. 10 concept questions. Okay, all right. Concept questions, the same as quiz 5. Yeah. Yeah. And given this weekend. So I will post this weekend. Okay. All right. This weekend, but I hope early weekend, not late weekend. Okay, late weekend because you can use weekend to do a little bit. Okay, yeah. Given this early weekend. Okay. All right. Now, hopefully Saturday morning you can see it. Okay. Yeah, I'm targeting Saturday morning. Yeah. Yeah. So I may do Friday late night. Yeah, but you will see Saturday morning. Yeah. All right. And duration 1 week. Okay, yeah. Similar to our old quizzes. Yeah. 1 week. Yeah. All right. But as for the counting, yeah, because remember because in our syllabus 6 quizzes we drop 2, right? We drop 2 of the 6 quizzes. Yeah. But if 5 of them we drop 1, right? Yeah. 5 we drop 1. Yeah. Yeah. Run 1 lowest. Yeah. Yeah. Okay. Yeah. 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 All right. Yeah. Yeah. So that's the. That's one. Another way I used before. Yeah, still drop 2. Yeah, 2. Then we only have 3 quizzes, 3 scores to be used. But 3 scores, I scale it to 4. I multiply 4/3. Okay, I multiply 4/3. I stretch it to 4 quizzes. Yeah, same amount of the 4 quizzes. That's another way I used before. Okay, still drop 2 quizzes, 2 lowest. Yeah, then stretch to 4 scores. Stretch 3 scores to 4 scores. Multiply 4/3. Yeah. Yeah. That way. Okay, I used before. Yeah. Okay, yeah. So probably you may like this way. Yeah. Because you can drop 2 lowest scores. Yeah. All right. So that's the part A. Yeah. Part B. So here I use this B and C mainly for the content characterization. Yeah. Not for testing time. Testing time we do not separate. Okay. Testing time altogether. Okay. But content, Content, yeah. Because part B, 10 basic questions. Okay, 10 basic questions. Here, basic question means not very hard, okay? Yeah, not very hard, just, checking your knowledge. If you know those formulas, those basic methods, basic things. Yeah. If you are familiar with the basic content, I cannot check everything, because I have, limited number of questions I can use. So I just check, things I feel important. And based on our homework assignment number 2. Yeah. Number 1, we forget about it. Okay. Number 2. Yeah. Only number 2. 10 basic questions. Yeah. Later I will jump to the, those questions. I will talk about which one I like to test. Yeah. How do I want to test it? Yeah. All right. That's part B. Part C. 5 hard questions. Relatively hard, not too hard. Yeah, but you need to make some effort. Yeah, it's not that easy. You need to, really do some non-trivial work. Okay, non-trivial work. Okay, all right. 5 hard questions. Okay. Yeah. So total 15 questions. Yeah. Yeah. Because you already in your midterm, you saw those questions. So what are those questions, basic questions look like? What are those, hard questions look like? Yeah. So you have some idea. Yeah. All right. Yeah. Yeah. All right. Then let me move to homework assignment number 2. Well, I haven't graded. Yeah. So here, I cannot talk about the common errors in your homework assignment number 2. Yeah. But here I just talk about the question types. Yeah. So what questions I like to, give you, and how do I want to modify, Yeah. I'll give you that kind of information for your preparation. Yeah. All right. So let me go to the, yeah. Yeah, let me get out. All right. All right, so this homework assignment number 2. Yeah. All right. We only do the computation questions. Okay. All right. All right. All right. Yeah. So for a question like this, because the first question too easy. Yeah. So this one I won't give you in the final. Okay? Yeah. So for this one I won't give you. This we treat as a trivial. But for this one, I will give you. Okay? This question, still insertion sort. Yeah. But I will give you the, specific order of these elements. Yeah. Yeah. The order. Yeah. The order will be different from this one. Yeah. I changed the order. Yeah. Okay. I changed some order, but I give you the specific order. Okay. Yeah. Then I ask you, how many comparisons do you need? Okay. Yeah. I changed the order slightly different. Yeah. Yeah. So now you need to know how to run the insertion sort. Yeah. when we run our standard insertion sort. Yeah. Yeah. Okay? Yeah. You need to do, yeah. First insertion, how many comparisons? Second insertion, how many comparisons? And so on. Based on the given order, then you do the counting. Yeah. Yeah. All right, so that's one such question. Yeah. Here we have that one. Okay, all right. And quicksort partition. Quicksort partition. Yeah, so I like to test it a little bit, but I will test it in a different way. Okay. Quicksort partition. Okay. So I still give you array, yeah, and I ask you to do one partition. Okay. Yeah. So similar to this one. Okay. Yeah. Do one partition. Yeah. Yeah. But I do not ask you, so my question, so yeah. Do one partition, okay, but I want to ask you, ask for the number of swaps. The number, how many swaps do you need to do? You need to give me that number. Okay, count the number of swaps. Yeah. 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 You do not need, if you give me partition or not, that's not important. You just tell me how many swaps you need to do in that partition, okay? Yeah. Because only when you can do that partition correctly, you can tell me the correct number. Yeah. If you guess one, then it's very likely it's not correct, okay? So you need to know how to do it, okay? So I ask you for the number of swaps, and not comparisons, swaps, okay? Including the pivot swap, okay? The last one, you put the pivot element in place. Also count that. Yeah, do not miss that. Okay? Yeah. That's one question. Basic question. So these are the basic questions. Okay? All right. There. Best case, worst case. Yeah. So here, yeah. Although I want to test it, yeah, but I try to test it in yeah. Oh, one thing I need to tell you. Yeah, one question. I remember Randy asked me before. I mentioned in class before. I said I may give you some question related to heap, right? Examples, but today we don't have that time. So then forget about it, okay? That was the example. Yeah, in my plan, because I want to give you 3 or 4 examples in class. Then in the final, I will do a few questions. But today, why not? I feel this hashing introduction more important. So I would rather spend time, because you may need to use the hashing many other places. Yeah, we will use hashing, background knowledge. So then I spend time on the hashing part. Yeah. So then the heap related computation questions. Heap part we only do the concept questions. Yeah, we will not do the calculation questions. Yeah. Just as a background knowledge. Yeah. Okay, all right. So that's something I want to say, yeah, for the final. Then the best case, worst case. So I only want to do one of the two cases, not both. Yeah. The best case, worst case. Yeah. Not both. Okay? Yeah. All right. So one of the two. The two cases. Yeah. Okay? One of the two cases. Yeah. Because we have other things to cover. Okay? So I don't want to waste too many questions on the similar topics. Okay? All right. Then best case, worst case. Yeah. 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 That should be enough. Okay. Yeah. So merge sort. Yeah. That's just the. Yeah. Yeah. All right. Yeah. All right. Yeah. Then, but the merge step, regarding the merge step, so actually these things, yeah, so let's go to here. Look at this question. Merge three ordered arrays and merge, three ordered array, best case, worst case. Yeah. So these two, I want to do one of the two. Okay? One of the two, which one? Yeah, so here, I'll give you some more information. Yeah. Information here, all right? Yeah. Based on these two questions, based on these two, yeah, so you did, based on these two questions. Yeah, all right. Best case, worst case. One of them follows the greedy algorithm. Do you still remember greedy algorithm? Yeah. Actually, this worst case can be solved by the greedy algorithm. So what's that greedy algorithm? Okay? When you merge first two arrays, you look at what two arrays are shortest. That's the greedy strategy. Okay? So you pick the shortest one, second shortest one, that's your first merge. Okay? After you do the merge, you get a larger array, right? Then you apply greedy strategy to select next two. Every round you select two shortest array to do the merge. That's the greedy strategy. And this worst case, greedy strategy will guarantee you get a best solution. Okay? Yeah. But best case not. Okay? The best case, this case, the greedy algorithm does not work. Okay? Yeah.
When you say the worst case, did you mean the worst case like using the worst case formula to
Yeah, well,
or
right.
worst case? Because you can merge them in three different ways.
Yeah.
The three elements that result in different
Right.
numbers of computations. So
Yeah.
if a question like this came up on the exam, using the worst case formula, or
Yeah.
Worst case.
Best, worst, always best, worst case, okay? Don't confuse, you find the worst case. That's bad, all right? Yeah, always best, worst. But, yeah, but Evan, here, for your question, worst case formula, because you talk about formula, okay? So here, yeah, because best case formula, this greedy algorithm doesn't work, okay? Only for the worst case formula it works, okay? Yeah, so the worst case here means the worst case formula, this formula, okay? Yeah.
Yeah.
If you use the minimum that formula, what greedy strategy doesn't work, okay? The greedy strategy doesn't work. Yeah. Or you need to use some completely different greedy strategy, yeah, because you can define your greedy strategy. The greedy strategy will be different, okay? Very sophisticated, yeah. All right, yeah. But here, because here, I let you know the greedy strategy works. That means you can apply greedy strategy. Then you don't need to do 3, 4 cases, right? Many cases. Yeah, too slow, right? Then I may give you need to merge more arrays, not 3. 3 too easy, right? I may ask you to merge 5 arrays. 5 arrays of apply greedy strategy, it's not that hard, right? Yeah, one, first 2, next 2, next 2, you know how to merge. So it's not hard. So then you may expect to merge 5 ordered arrays. In this case, 5. Okay? So that's why you have to use greedy strategy. Otherwise, 5, how can you do all the cases? Impossible, right? Too many. Nobody can do that. Okay? So you have to apply the greedy strategy. Okay? Yeah. So merge 5 ordered arrays. Okay? To, make you understand the importance of the greedy strategy. Yeah. Yeah? Yeah. All right. I only have, minutes. I cannot talk, other questions. Yeah. Other questions. Yeah. All right. Yeah. Yeah. Anyway, I don't have time to talk about other questions. Okay? Yeah. Just give you some information. Okay? Give you some information, For the other, I do not mention, you just follow the homework assignment number 2. Okay? Yeah. Homework, when you do preparation, right? Preparation, focus on these questions. Yeah. Yeah. All right. Yeah. Oh, one more thing. Yeah, I have 2 minutes. Yeah. Regarding the hard question. Yeah. So last 5 regarding hard questions. Yeah. 5 hard questions. So I give you the typical questions I will ask you. Yeah. 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 Typical questions. Okay? All right. Sorting is one. Yeah. I call the conditional sorting. How about that? Yeah. It's not given a 7-element array, for example, but I give you partial information, partial order information. Okay? Yeah. Yeah. So you do not, so that there are some conditions. Okay? Yeah. So I can call it conditional sorting. So that's one type, okay? And conditional finding the median, okay? also under some condition. Then you find the median, all right? Yeah. Okay? So that's the, two types of questions. Yeah. In the hard question category, okay? Hard question category. When you do preparation, Yeah. Curious?
Are those the only types of questions, or there are more? Or just those two?
Oh, those two category, yeah, because conditional sorting, I will give you two, right? Yeah, question. But it may not be, because some could be, find the second largest, some could be find the third largest, right? Yeah, so could be second or third largest, and conditional, okay? All right? Yeah. So things like that, okay? Things like that. Okay? Yeah. Yeah. But won't be the midterm type. Midterm, we have a lot of the element, not the maximum, not the minimum, or things like that. So those questions I won't give you, yeah, because midterm, yeah, we pass it, okay? We won't go back, okay? Yeah, so maximum, minimum, not the maximum, not the minimum, no those questions, okay? Yeah. We do new questions. Yeah. All right, that's it. Yeah.